So in the past, we've had a function as, x's, and we've got what with the x's. We've got the dx, the change of x with the x's. Or we've got a function in terms of y, we've got the dy with those y's. So today we've got a function in terms of x's and y's. So you want to get the x's with the dx's and the y's with the dy's. Because we're doing a rate of x changing and a rate of y changing. So there's so many applications of this. It comes up a lot in science, like you have rules or functions in terms of two different variables. You want to find the rate of change of this function, so you get the variables with the rate of change corresponding to each other. So let's just do a fairly simple example. So you've got a function 3xy, and what did I say to do first? Get what with what? Correct, yep. So it's got dy over dx. We can bring the dx to the other side by multiplying both sides by dx. So we've got the x with the dx. What do we do to get the y with the dy? Yep, divide both sides by y. But why? Now we integrate both sides. This is a constant, so we can bring that out the front of the integral. So yes, get the y's with the dy, the x with the dx, and then integrate. So 1 over y, in terms of y, what's that integrated? Natural log of y, what's this? Just integral of x. So you add 1 to the power, becomes x squared and divided by 2. And we add a constant. So the inverse of natural log is e. So it's e to all of that power. And one way to define the plus c, you don't have to do this. Sometimes it's easier when finding a particular solution, is changing the plus c into a capital A, which is a coefficient instead of a power. And this is just the same as e to the c because of power rules. If you have a power plus a power, it's the same as that times that. I don't know if you remember that from grade 8 and stuff. I'll just go through the solution. It's pretty similar to the example we just did. So I'm trying to get the x's with the dx and the y's with the dy. So bring the y over, bring the bring the dx over, you're left with this. Then integrate both sides. This becomes y to the negative 2 plus 1 to the power. Divide by that new power, which is negative 1. This is x to the 1, so it becomes x squared. Divide by that new power, so that becomes 6. 3 times 2 plus c. Any questions for those watching? So this is now 1 over y equal to So what I was trying to describe last time is when you get to this point, you can actually sub in this. So right now we can sub in 1 over, is it negative? Yeah, negative a half. So that gives us C is equal to negative 2. And yes, then we need to do the inverse of this, and which is the opposite of negative 1. If we do both, if we do that to the negative 1, so then we do all of this to the negative 1. Sorry, that is the particular solution.